All right, good morning, 3Us. So we are on to the third day. You guys have different lessons than the 3M and 3Cs. Today they're doing their test review and an assignment that you'll be doing tomorrow. So today's lessons are on rational expressions. So it is a little tricky, and for the test, I'm only going to give you one question with it because it takes quite a bit of time and it's a pain in the butt. But we do have to cover it. So that's the scoop on that. So I'm going to pull up your work right here. So your first task is to do quiz number 2, and you're still going to have 3 videos for the lessons here. And yeah, so your first quiz or your second quiz here, and then we're going to look at simplifying rational expressions. When you hear the word rational, that doesn't mean like up in the head or anything. Also, I know I realize that I look like little Michael Jackson kind of it's just for the drawing tablet. So when my hand skims on the tablet, it doesn't like register that, it just registers the pen instead. So the learning goal for today is to simplify rational expressions. So rational expressions are equations that are in fractions. So there are quite a bit of work, and it is possible to make quite a bit of mistakes just from not seeing something, etc. So a rational expression is a sum, a difference, a product, or quotient of terms. It may be a quotient of 2 polynomials. So for example, if we have x squared plus 7x plus 12 over x plus 3, that is an example of a rational expression. Okay, so like I said, it's just a fraction, and I know fractions aren't fun to do. I don't know a single person that really likes them. So that's the gist of it. So the important thing to know is that the denominator cannot have a value of 0, can never, ever, ever be 0. You can't divide anything by 0. It doesn't give you an answer. So that means that the result is indefinite, or undefined is the word that I was looking for. So you can never have 0 as the denominator, which is the bottom number. So that's why we have restrictions for those variables, for those denominators, because yeah. So for example, restriction for, I just need my pencil here. So the restriction for the first one here, so we don't want the denominator to be equal to 0. So that means in order for the denominator to be equal to 0, what you do is that was great writing, yep. So you take the denominator, you make it equal to 0, and then you find what x would be that would give you 0. So like what plus 6 gives you 0. So one way to do that is to solve for the variable. So you want x on its own. So you're going to subtract 6 on both sides. Whatever you do on one side, you do to the other. Okay, so plus 6 minus 6 cancels out. So x and 0 minus 6 is negative 6. So your restriction would say x cannot equal to negative 6. So if x were to be negative 6, so negative 6 plus 6 gives you 0, that means that this rational expression is undefined. That means that we can't, like, it's not doable. Okay. So here, same thing as well. So it's convenient with these guys when they're multiplied. Anything multiplied by 0 is going to be 0. So x can't be equal to 0, because if x were equal to 0, that means it would be 2 times 0 times whatever y would be times whatever's in here. And no matter what, it would just be equal to 0, and it doesn't work. Same thing with y can't be equal to 0. And then the next one would be x minus 2 is equal to 0, and we solve for x, so x cannot be equal to 2. So those are our restrictions. So x can't be equal to 0, y can't be equal to 0, and it can't be equal to 2. I hope that makes sense. Okay, and the same thing here. So what you do is you take the denominator and you're going to set it to 0. -1, we want to bring it onto the other side. So +1 on both sides, this cancels out. So we're left with x squared is equal to 1. The opposite of squared is square root, so that cancels that out. And the square root of 1 is 1, so it cannot be equal to negative or positive or -1. It can't be equal to positive or -1. Okay, so that's how we find the restrictions. You just make it so the denominator is equal to 0 and you say, hey, this variable can't be equal to this, it can't be equal to that, etc. So then to simplify rational expressions, our first step is to factor all of the polynomials, and this is where it gets a little tricky and it's a little bit of a pain in the butt, and it can take quite a while to do, to be honest. That's why I only put one question on your test, and if you don't get it, you're only losing a few points, not the end of the world, okay? But please try. So you factor, you tell me the restrictions, and you cancel out common factors. So if we look at our example down here, we have x plus 2. You can't factor that any more than it already is. But you can factor the denominator. So x squared minus 4, that's a difference of square because we can do the square root of both terms. There's only 2 and there's a negative in the middle. So our answer here would be x plus 2, x minus 2. Okay, so that means that our rational expression will look like plus 2 minus 2. Okay, so there's that. So that's our first step. You factor the polynomials. So then you have to state your restrictions. So x cannot be equal to -2. And x cannot be equal to 2. Okay, so that's our second step. Our second step is to state the restrictions. And then you're going to cancel out common factors. So what you're going to do is anything that is the same, so x plus 2 and x plus 2 right here at the numerator and the denominator, those can cancel out. So the reason being is if you had 2 over 2, 2 divided by 2, those can cancel out and it'll just give you 1, okay? So you can cancel this one out and cancel that one out because they're the exact same thing. When you cancel out anything or the whole thing at the top, that gives you a 1. There's an invisible 1 that's there. It's always there. And then this is gone, so we're left with x minus 2. Okay? So our first step, factor, tell me the restrictions, and cancel. So I'm going to clear that. We're going to do a few more examples. Okay. So examples. So the first one's relatively easy. You don't need to factor anything, which is nice. So this can be, we can simplify this guy. No, I just need my pen. This guy would be the same thing as that. And then if we have this, and hopefully you remember your exponent rules. So this is all the same. So pretend those are all multiplied and they're all divided up into these little parts. Okay, so 4 and -10, that could be simplified into 2 over -5. They can be divided by 2, right? So that's simplified. That's a regular good old fraction that everybody hates. And then here, so pretend that there's a 1 here. When you're dividing exponents, what you do is you subtract the exponents. So this would be x to the power of 2 minus 1. So this we would be left with x to the power 1. And remember that that's on the numerator because the number is higher. And then here we've got y10 take away 5. So we're left with y5. So in a much better written way, this would look like this, okay? We didn't state our restrictions, so here we're just gonna look at our starting one. So x can't be equal to 0. Anything times 0 is gonna be 0, and y can't be equal to 0. Okay, that's it. So that's nice and simple. Here we have two trinomials. They are simple trinomials for factoring. So our first step that we're gonna do is we're gonna factor the top. So a squared plus 4a plus 3. So we find two numbers that multiply to give us 3, that add to give us 4. So those two numbers are quite simply just 3 and 1. Okay, so you guys should know this. I did say it in the other video with the college group. So factoring is super duper important for this whole course. If you do not understand, please reach out to me so I can make sure that we get that on lock, because you're going to struggle quite a bit during the course if you don't understand. So please just let me know. Hopefully it is review for you guys and you're like sitting there like, oh yeah, I remember doing this in like grade 9 or, you know, grade 10, even though most of grade 10 was probably online for you guys, which doesn't, it's not super great, the whole situation. So then you're going to factor the denominator here as well. So two numbers that multiply to give you 6 and add to give you 5. So that again is just simply 3 and 2. I'm not going to sit here and do the whole chart with you guys. Hopefully by now we do understand how to do this. So if we look at this, we're going to state our restrictions, okay? So a cannot equal to -3. If we had -3 here, -3 plus 3, that would be 0, and anything times 0 is 0. And a cannot be equal to -2. Okay. Now our next step is to cancel anything out. So we have a plus 3 and a plus 3 that are canceled out because they are the same. And we are left with a plus 1 over a plus 2. Okay. Hopefully that's simple enough for you guys. I'm going to clear this and do the next 3 examples. So clearing. I need my pen. Okay. So this is where it becomes a little bit more work. So our numerator, the arrow is supposed to go like this. So the numerator, the top part of the fraction, is a complex trinomial. We looked at those yesterday. I'm not going to go through the whole process of decomposition with you guys. I'm just going to give you guys the answer for that. So when you do decomposition, so complex trinomial that you guys had seen yesterday, our answer comes up to 2m minus 5. Where am I? M minus 2. Okay. If you had troubles with decomposition, again, let me know and we can go through it together. And then our denominator here is a simple trinomial. So two numbers that multiply to give you 6 and add up to give you -5. So that would be -2 and -3. Okay, so our next step is to state the restrictions. So m cannot be equal to 2 and m cannot be equal to 3. Okay. Now our third step is to cancel anything out. So even though they're not directly under each other, they're still in a rational expression. So you would still cancel these guys out. They're the same. And that would give us 2m minus 5 over m minus 3. My writing's great. Okay, so same thing with our top part here. So my face is a bit in the way here, but whatever. So because we have a number in front of our a squared here, that means it's going to be a complex trinomial. Again, I'm not going to do the factoring with you. So factored together, that gives you 2a plus 5b and a plus 3b. I'm hopeful that you guys know how to do that part. And then the denominator is quite simply just common factors. They have the common factor of negative 4a. So we're left with an a plus 3b is what we're left with. Okay, so our restrictions are that a cannot be equal to 0 because of here. And a cannot be equal to negative 3b. So that one. Okay. And then we cancel out. So we have a plus 3b that are the same. So those cancel out. And we are left with 2a plus 5b over negative 4a. Hopefully that makes sense. So I'm going to clear that. And there's our very last example down there. And then you guys are on your own to do some independent work. And there's 2 more lessons. Yeah. Moving down here. Okay, pen. So if we look at our numerator here, all there is that you can do with that guy is a common factor. So you can common factor out x, and we're left with y minus x. And same with the denominator. The denominator, you can take out a y that is common. So you're left with x squared minus 3 squared, minus y squared. If I could get lessons on my alphabet, that would be really great, I think, because I'm struggling right now. The thing here is that we're not done just yet. So with this guy here, it is a difference of square. Even though there's no numbers there, there's still 2 terms. There's a subtraction in the middle, and you can square root both of these. So this would actually be equal to y is equal to x minus y and x plus y. You'll see here that this is very similar to this. The only difference is here you have to take out a negative and it swaps that over like that. Okay, so I'm going to rewrite this so you can see it. So negative x times x minus y over y x minus y x plus y. That way you have a common bracket that you can cancel out. Very lopsided. So our next step, hopefully I'm not losing you guys, is to state our restrictions. So y can't be equal to 0. X can't be equal to y. X can't be equal to negative y. And the opposite as well. Okay, goes both ways. These 2 cancel out. We are left with negative x over, that was a great y, yep. Y plus x plus y. I'm doing great with this writing stuff today. So that is all for that lesson. You have quite a few practice questions there for you. If you find the repetitive, actually no, it's best you do them all, to be honest with you. It is quite a bit of work and it's a loaded day today. So that's why Ben is